Thank you very much, and it is also an honor to be here today. And as we know, as we've heard all afternoon, technology is the key to success. Unfortunately, there are some groups that don't have the exposure or don't have the interest in technology and in the STEM education area. And one of the areas that I specialize in trying to get the word out to is females in the STEM education area. Being an airline pilot and in the aeronautical science area, the female population is vastly unrepresented in the science and technology area. This includes education and in the career path. STEM education has been a male-dominated path with only 37% of the science and engineering doctoral degrees being earned by females and only 13% in the aerospace industry. But what can we do about that? Can stronger STEM education enhance the changes to bring more females into this path? And this is what we're hoping computer-based math can help us to achieve. To get the word out to females, get them interested by using real-world applications. And my specialization is aviation, but as we know, we can also take other specialization areas and incorporate these into the computer-based math. The key is to help their interests grow. And interest is what the key is for curiosity. That piques questions, that piques education and lifelong learning. Without that, the female population thinks that math is too hard, as we've heard earlier today. And math, we know, is not hard. When we take the real-world applications in aviation, such as weight and balance, computers, fuel calculations, navigation, distance, aerodynamics, we know that these are used on a day-to-day basis. And for the young people that think that math is boring or science is boring, when you introduce them into aeronautics and aviation and aerospace, they think these subjects are very interesting. And we can take this and apply it to real-world applications. In the United States, only 7% of all pilots holding an airline transport pilot certificate, that is the highest level certificate, are female. So they're vastly unrepresented. All the major airlines have at least only 1% female airline pilots. And the only reason for this is we know it's not hard. Math is not hard. Science is not hard. Some of it may be due to stereotype or bias, but the majority may stem back from their early education roots when they're thinking it is too hard. We must get them engaged. We must show them that this is something they can do, that it's fun and easy to learn. Many times I go into schools and I talk to the young people during career days and other times. And when I ask them if they've thought about aviation, they said no, for the same reason, it's too hard. And I ask them, what do they like to do? And the majority of them say computers. Of course, most children, as we talked about, do video games, do computers. And I let them know a little fact that on an airplane, the Boeing that I fly, there's over 200 computers. So the majority of our work is learning computers and the math and the science that's involved with this, and that helps pique their interest. So by enhancing the STEM education with the help of computer-based math, we can pique their interest, which will lead to greater career opportunities. And these are some examples of computer-based mathematics applications in aviation for navigation, flight simulation, aircraft movement, ratio formulas, vector formulas. And also, computer-based math is not only limited to young people and young students. Currently, in the training sector in aviation, there's simulation used, and there's also a lot of classwork time used, and that is going over to computer-based mathematics. And there's also a problem going on because of the older pilots in airplanes that had did everything by hand. They're not used to the computer-based training. So this is an area where computer-based mathematics can be enhanced and can be used to train these pilots to better utilize the newer technology. As we all know, technology is what is driving the future for today's youth. Thank you.